Hi friends, welcome back. Today we are going to solve another popular binary tree related coding interview question, prime binary tree. So we are going to go through this problem, understand this problem with few examples, and we are also going to implement our Java solution code to solve this coding problem. If you haven't already subscribed to this channel, please subscribe to this channel now. Also click on the bell notification icon button right away so you won't miss any important postings from this channel. Here we create videos to help others in their interview preparation and learning different computer science concepts along with data structures, algorithms, problem solving, Java programming and coding. So let's start. A binary tree is called prime tree if all the nodes in the binary tree are prime numbers. Write a program to find out if the given binary tree is a prime tree or not. Print true if it's a prime tree, otherwise print false. Prime numbers are numbers that have only two factors, 1 and themselves. See the example below. Okay, so we'll go to the example so you'll understand what the prime tree means. So this is one example of a prime tree. So as you can see here, this is a prime tree because all the numbers are prime numbers 13, 23, 31, 29, 53, 37, 59 and 11. See, these are all prime numbers, right? So that's why the output is true. Correct. Now let's take a negative test case. So this is another example. This is similar tree, but this is not a prime tree. Why this is not a prime tree? Because of this. Because this 32 is not a prime number, right? So all other numbers are prime number, but one number is not a prime number. That's why the output is false. So this is not a prime tree. Okay. So this is what the problem is asking us to find out. So you understood the problem clearly, I hope, with these two examples. So how can we solve this problem? So we can solve these kind of binary tree or binary search tree related problems using recursion. Many times you can use recursion to solve these kind of problems. So how we can solve this problem? So to make sure if this is a prime tree, what we have to make sure that this node is a prime node, right? This one should be a prime number and the left subtree should be a prime subtree and right subtree should also be a prime subtree. Correct? You got it, right? Okay. Now when you go to the left side, this should be a prime number and left subtree of this node and right subtree of this node should be also prime number. So this is how the recursion will work internally, right? So it will go down here. So you will get true from here, right? Because this is a prime number. Then you will check 29 is also a prime number. Yes, then you will return true from here, right? So this is a true. From here 53 is a prime number, so you will get true. So this is true, this is true. 23 is also prime number, so it means that it will return true from this side. Correct? Okay, this is how the recursion will evaluate the code, right? That's what I'm showing you. So this one will return true because 37 is a prime number. If this is 59 will also return true, and this is true, and this 31 is also a prime number, so you will get true from both sides. 13 is also prime number, so it will return you true. Basically it means that it's a prime tree. So we can use this logic to solve this problem using recursion. So this is a recursion basically, right? This is another example where how recursion will work here. So from this side, right, from this side you will get a true because everything is prime node, so you will get true from this side. But from this side here you will get true because 37 is prime node, 59 is a prime number, so you will get true. So but 32 is not a prime number, right? So you will get false from this side. So when you evaluate true and false, right, true and false evaluate to false. Correct? True and false evaluate to false. It means that this is not a prime tree basically. Correct? Okay, so this is how the recursion will internally work. So let's go ahead. So how will we check the prime number? So we can use or we can write our own custom static method to check prime number, right? Utility method we can write down so that you just pass a number, it will check if it's a prime number or not, right? So checking a prime number is pretty easy. So I'll show you that in a minute. So this is how you can solve this problem, right? So let's go through the code so it will be more clear for you. So this is not an odd even tree, this is a basically is a prime tree, right? So this is a prime tree actually, right? So So this is the prime tree is the method we are implementing. A root of the tree is given to us, right? Root of the tree is given to us. So we will create one boolean variable, result is true, and we will call our recursive method helper, where we will pass the root of the binary tree, which will return us the result, true or false, right? That return we will have to return from here. So this is the main method here, right? So the main method is a helper method, which is a recursive method. So you get a node here, which is a tree node object, right? And this is the base case of recursion. If node is null, you will return true, correct? If node is null, you return true. Why we do that? Because for example, when you go to 37, its left child is null node, right? Its right child is null node, right? So in that case, you have to return true from both the sides, right? So that's why we are returning true here. This is the base case of recursion. So let's write down here the base case of recursion, right? So why do we need the base case? The base case is required so that the recursive method knows where to terminate, right? Otherwise it will go in the loop. So that's why we need a base case. Now we will check if the node, this current node, should have the primary number, right? So we'll check if this is a primary number. If it's not a primary number, you will return false. So it cannot be a prime tree basically, correct? If you find out any number which is not a prime number, then it cannot be a prime tree. So you will return false here. Let's say this is a prime number, then you have to check both the left side and the right side of that node, correct? So what I mean to say is, let's go here, right? So if this is a prime number, yes. So if it is a prime number, it doesn't mean that this is a prime tree. You have to still check the left part of this subtree and right part of this subtree. You have to still check both the sides, right? That's why we are going to go into recursive method here. Helper method, we are going to go to the left side of this current node. We are also going to go to the right side of this current node here, right? So you get two values. One is left value, one is right value. Left and right value you will get, right? So both should give you true values. Then only it can be a prime tree, correct? So as I explained you, 13 is true. It doesn't mean that the whole tree is prime tree, right? You have to evaluate this whole part on the left side. It should give you true from this side. You have to also evaluate this right part and it should also give you true from this side. If both are true and 13 is also prime number, then only we can say that the complete tree is a prime tree, correct? This is what exactly we are doing here. So you get two answers here. One is from left side, one is from right side, and you are taking a AND operation. So left must be true and right must be true. Then only it's a true, correct? Okay. So this is what the how you can implement this prime tree solution. So now this is our helper method is prime number, right? So is prime number is our helper method. So this is how you can check if the given number is a prime number or not. So this is just a static method, right? So flag is equal to false in the beginning. You will start looping from I is equal to 2, I is less than equal to num divided by 2 plus I, right? So why num divided by 2? Because if you don't find any division until the num divided by 2, then you don't have to go all the way until the end of num, right? So only you have to check until num divided by 2 for prime numbers, right? That's why. Okay, then you will check num mod I. If it is equal to 0, it means that it is divisible by some number. If number is divisible by some other number except 1 and itself, right, then it means that you will set the flag to true, because uh, it's not a prime number basically, correct? And you will break. If the flag is true, then you will return false, right? You got it, right? If the flag is true, it means that it's not a prime number basically, correct? Right? So we can do it in opposite order also. Both are fine. So it's just a flag, right? So flag true means it's not a prime number in this case, right? So if it is true, then you will come here, because this one is a negation, right? Or you can just say that if flag is true, then you will return false basically, otherwise you will return true. Both are same thing basically. Okay, so this is just to check the prime numbers. um, that we are calling from here to check if every node's value we have to check if it is a prime number or not, right? If it's not a prime number, you will return false. So now we are going to test our code on this method, right? Sorry, on this tree. So we should be getting true here because all these nodes are prime nodes basically. So this is the same tree that you can see all these nodes are there, 13, 23, 31, 29, 11, 53, 37, 59. So all these nodes are prime nodes. So we are going to expect that we should get true here. So let's execute this. We are getting true, which is a correct answer, right? So we are getting the result and printing the result here. So true is the correct answer, as you can see. Now let us do one thing. So let us change this value of um, 31 to 310, right? If I put 310 here, then it cannot be a prime tree, right? Because 310 is not a prime number, so you should get false now, right? You are getting false here, which is a correct answer, right? So this is, it is correctly checking and understanding if it's a prime tree or not. So our solution is working correctly. So this is how you can implement this recursive solution to solve uh, to check if the given binary tree is a prime tree or not. So I hope you understood this recursive solution completely, and how we have used recursion on the to go to the left side of the subtree and go to the right side of the subtree because we have to check the complete tree, right? To make sure that the whole tree is a prime tree. So I'm going to add this Java code in my GitHub repository, and I'm so that you can go and check out the Java code. There are lots of other important algorithms and Java solutions already implemented and available there for you in the GitHub project. So do check out the GitHub repositories. They are important ones from interview perspective, and it's definitely going to give you a good preparation for your interview rounds. The name of the playlist is LeetCode and LeetCode Solutions. If you like the GitHub repository solutions, consider giving it a star on the GitHub repository. Do check out the very important playlist from this channel, LeetCode and LeetCode Solutions. More than 200 most frequently asked, very important coding interview problems are compiled for you under one playlist. Those problems are asked by Google, Facebook, Amazon, Apple, Microsoft, Yahoo, Uber, Lyft many times in their past interviews. They are very important coding interview problems. Make sure you go through all of them, understand them very well. If you go through those problems and videos, you are going to learn a lot about data structures, algorithms, problem solving, logic building, Java programming and coding. It's also going to help you learn lots of new techniques and lots of new ways of different varieties of problem solving on this channel. So do check out those solved problems. The name of the playlist is LeetCode and LeetCode Solutions. If you are a fresher, junior level developer and you want to practice more coding problems for your interview preparation purpose, there are 3 other playlists we have created for you here. The names of those playlists are Codeforces, CodeChef, AtCoder. Codeforces, CodeChef, AtCoder. All in all, more than 800 different varieties of problems are here to help your interview preparation and learning process. If you like this Java solution where we have used recursion to solve this important coding problem, if the given binary tree is a prime tree or not, then please give it a thumbs up to the video, give it a like to the video, subscribe to this channel. Subscription is very important because that's how the videos can reach to other people. So others will also be able to watch and learn from these videos. So do subscribe to this channel, share this video with your friends and colleagues so they can also watch and learn from these videos. More programming and problem solving. Click on the bell notification icon button right away so you won't miss any important postings from this channel. On this channel, you will find lots of solved coding problems which are important ones from interview perspective. Those solved coding problems varieties includes graphs, matrices, binary search trees, breadth first search, depth first search, cadence algorithm, binary search algorithm, Kruskal's algorithm, Dijkstra algorithm, sliding window algorithm. There are also lots of important data structure questions available for you here, including stacks, queues, priority queues, hash table, hash map, tree set, hash set, linked hash map, linked hash set, arrays, linked list. All those different problems are important ones. You will get good preparation for your interview rounds. You are also going to learn lots of new things from this channel. If you are a fresher, junior level developer planning to take Java rounds of interviews, there are lots of Java related videos available here. For example, frequently asked Java telephonic interview questions and how to answer them, Java design patterns, Java architecture, SQL programming questions to the freshers, where they will give you database tables. They will ask you to write SQL queries where you have to use different database concepts like joins, aggregate operations, group by and having clauses, different where clause conditions. Everything is explained in those videos with examples and SQL queries along with database tables. There are videos that discusses recently asked questions to the freshers about Unix, like Unix commands, Unix utilities, shell scripting questions. All are here to help you in your interview preparation process. If you like the videos on this channel, if they are helping your learning process, you are learning more techniques, more problem solving along with Java programming, coding and data structures and algorithmic techniques, then please do leave your messages, your feedback, your comments below these videos. Your feedback, your messages and comments are highly appreciated, very important and valuable for us. They increase our motivation to create more quality content videos. So do leave your messages below these videos. Tell us how the videos are useful and helpful for you. If you want us to create videos about any specific computer science, Java J2E or interview related topics, then also mention those topics in the comments section below this video so that we can create those videos for you here. Keep learning, keep coding, keep solving more varieties of coding problems, and most importantly, keep your learning process and practicing going on continuously. And thanks for watching these videos.